Number one says the weights of Triton football players are normally distributed with a mean of 194 pounds and a standard deviation of 11 pounds. Notice I underlined they're normally distributed. What we mean by that is that we have a distribution that's not skewed to the left or skewed to the right, right? So in that first chapter we talked about that skewness, that the mean is affected by skewness. It gets pulled to one direction or the other. But if we have something that's nice and symmetric, then our mean and median are equal. They're equivalent right there in the middle. So all of the problems that we're going to look at in this chapter and on this review all are normally distributed. I mean, they're all symmetric. It's all balanced. And because it is balanced, because it is, we have a certain symmetry here, then what we can then do is we have an idea of how much of the data points are contained within a certain area of our distribution. And that's the part we're going to kind of break down. So it says a mean of 194. So a mean of 194. Right, there's our mean of 194. Just some notation here. We use this, instead of writing out the word mean, we use this X bar. And for the X bar, that's just mathlish for mean, instead of having to write out that word. And then it says that we have a standard deviation of 11. So what do they mean by standard deviation of 11? Well, standard deviation, and just a notation on that, you'll see over here, see this kind of O with the calyx sticking out? That refers to standard deviation. So this little sigma guy, the Greek letter, is standard deviation. And what the standard deviation does is it measures how spread out the numbers that the other data points are from the mean. So most of the numbers, are they close to the mean, the average, or far from the mean? So it's a measure of how spread out or how far away from the numbers they are. So when you talk about our SOX, our shape, outlier, center, spread, one of our measures of spread is, in addition to range, is the standard deviation, how spread out are the numbers. So what it means is if you say a standard deviation of 11, basically what you're saying is that if you're going to count out 11 to this way, and you're going to subtract 11 in that direction. So what I mean by that is that if I wanted to know within one standard deviation, so we'll say this is one standard deviation, 94 plus 11, right? So I get 205 there. And then if I go out one more standard deviation, if I do another jump, I'm out now to 2 standard deviations. 11 more pounds, if I add on to that, would be 216. And then if I do one more standard deviation here, add on 11 more pounds, now I'm up to 227. Now, what this is representing, and we'll kind of refer to this here in a second, but basically you notice is that the thickest part of the curve, right, is here in the middle. And then it gets thinner and thinner and thinner as you move out to the edges. So what that means is that most of the football players, kind of weigh in the 190s-ish area. And then, but maybe we have a few that weigh heavier. Let's look at what it would be the other direction. So if I want to go one standard deviation to the left, I'm going to subtract 11. So I end up with 183. If I go another standard deviation, subtract 11, now I'm down to 172. And if I go one more standard deviation, subtract 11, now I'm down to 161. All right, so what this shows us is that if I look at this is referred to our empirical rule, or our 68, 95, 99.7. What it means is that between -3 standard deviations and +3 standard deviations, that's going to represent 99.7% of the distribution. So what I could say is that I could say 99.7% of Triton football players weigh in between 161 and 227. As I go in, 2 standard deviations represents 95%. So I could say that 95% of players weigh between 172 and 216. And then between 1 standard deviation is 68%. And these numbers are set, so it doesn't change for the problem. So it doesn't matter what the numbers are in the problem, these percentages are set. Again, assuming that we have data that's normally distributed. So what this would be, and I can kind of represent this, is that, so this represents 68%. So 68% of our players weigh between 183 and 205. If I want to go a little wider out, so if I go wider out here, that represents 95%. So 95% of our players are in between 172 and then 216. And then if I go 3 standard deviations out, now I have 99.7% of our players are in between 161 and 227. So basically everyone on the team is in between 160 and 227. Now, we went into a little bit more detail than what we needed to answer this question, but this is really kind of sets us up for the next 3 questions that come after this. So I wanted to kind of do the explaining on that part of it first. This question is actually a lot easier than what we've kind of set it up. The question is saying half of all players weigh less than what amount? Well, so we've broken out the 68, 95, and 99.7. Well, but this represents, we said because we have symmetry here, that our mean and median are equal. So our middle point right there is 194. So what that's saying, if we want to know half of all players weigh less than what amount, well, half of all players weigh less. Half of all players weigh less than 194. We could also say that half of all players weigh 1 over 194, but what we say here is half of all players weigh less than 194. 194 pounds. Units on there. Right, so half of all players weigh less than 194 pounds. All right, so pause here and let's try number 1 on the right side.